Hey guys, I'm Mr. Bevorkin. I want to do a quick problem with a linear inequality word problem. All right, so here we go. Potatoes cost $3 per pound and tomatoes cost $1 per pound. How many pounds of each type of food can I buy if I want to spend no more than $10? So the key here is right in those three words, no more than $10. That lets you know that it's an inequality, not an equation. So let's kind of think about how this expression would look like to represent how much he's buying. So $3 per pound for potatoes. So let's say X is pounds of potatoes. And let's say Y is pounds of tomatoes. All right, so X pounds of potatoes. I can't even talk right. X is pounds of potatoes, and Y is pounds of tomatoes. So, how could we write an expression here? Well, if it's $3 per pound of potatoes, I'm going to add that to $1 per pound of tomatoes, and that represents how much I'm buying. Well, however much I'm buying, it better be less than or exactly $10 because I can't spend any more. There's no more than $10. So if you only got $10 in your pocket, how much you're buying, the left side, better be less than or exactly the amount you have in your pocket, $10. So here's a nice looking equation. It's in standard form in a way, but we're going to go ahead and solve for y so that we can graph it really, really easily. So we're going to subtract 3x on both sides. Those cancel out, and we are left with 1y, or just a y, is less than or equal to negative 3x plus 10. Now, I know you could say 10 minus 3x, but we switched it around because we want to say mx plus b. We want to be reminded of that beautiful mx plus b. So, let's graph a line. Our y-intercept is 10, so we'll put a dot at 10. And our slope is negative 3, so that's negative 3 over 1. I want to go down 3 over 1. I'll do that a couple times so I can make it straight. Down 3 over 1. Down 3 over 1. Now, before I draw my line, I got to check, is this going to be a solid or dashed line? It's going to be solid because it has that or equal to. Okay, so it has that or equal to, so it's a solid line. So I'm going to draw my solid line here. It's pretty good. All right, and now I need to do my shading. Okay, I'll need a shade. So it says y is less than negative 3x plus 10. So I want to shade underneath the line. So I'm going to shade in this kind of triangle that's bounded by the x and y axis and by the line. I don't need to shade underneath the x and y axis because that would mean that I buy negative tomatoes and negative potatoes, and I don't really think there's any antimatter potatoes and tomatoes lying around. So we'll just kind of go with what's here. Now, since we're not talking about like bounding it by the axis or anything like that, we can assume that you can keep shading that way if you want to, but really, it's a word problem, so we want to go with something that makes sense. So let's talk about what that means. What does all this stuff mean? Well, the shaded region represents all of the solutions you can pick, all the possible combinations of potatoes and tomatoes you can buy, and we're going to assume that we can buy a fractional sets of tomatoes and potatoes. So I can buy like 2 1/4 pounds of potatoes. So I'm going to do that. And this represents all of those. So if I pick any point inside of that region, when I plug it in, it should be less than $10 because it's underneath the line. It should be less than $10. So let's check it out. So we had 3x plus 1y is less than or equal to 10. So I'm saying, how about the point 1 comma 2? What that means is 1 pound of potatoes and 2 pounds of tomatoes. So plug in 1 pound, $3 for 1 pound, plus $1 for 2 pounds. That better be less than 10. So that's $3 plus $2. And yeah, that is less than 10. That's $5. $5 is less than 10. So that totally works. We could also pick a point on the line. Now, the real cool thing is that all of the points on the line are $10. Those are all the combinations that you can get that are exactly $10, all the points on that line. So I'll pick, how about this point right here? What about 1 pound of tomatoes, 7 pounds of tomatoes? And you know what? I won't even plug it in. You can kind of just look at it and tell. Okay, 1 pound of potatoes would be $3. 7 pounds of tomatoes would be $7 because it's $1 per pound. Well, $3 plus $7 is $10, and that works because it's y is less than or equal to. Okay, so or equal to, that's supposed to be at $10, just really, really sloppy. So or equal to, that's why it works. Okay, and all these points that are above the line, well, those are points that would be over $10. So we have in this beautiful example, the shaded region is all the possible combinations of potatoes and tomatoes I can get that are under $10. On the line is exactly $10, and then above the line is over $10. So I think that's a pretty awesome example of linear inequalities and how they help out with word problems. All right, that's about all I'm going to do for this video today. I'm Mr. Bork, and that was solving linear inequalities with word problems.